ঠিক আছে, শুরু করি। So superposition, right? So superposition is obviously when you have two or more waves meeting at a point, and the resultant displacement is going to be the vector sum of the displacements of the individual waves, right? Superposition korte hole tomar the waves have to be the same type, they have to be on the same plane, they have to be meeting at a point, ঠিক আছে, তখন গিয়ে they can interfere with each other. Different types of wave hole but বেশি different frequency hole তখন they won't be able to interfere. Right, তারপরে stationary waves. First of all, this is something I want to talk about. Stationary waves, which are also known as standing waves. ঠিক আছে, কি কি জানতে হবে? Principles of superposition in simple applications, understanding of experiments that demonstrate waves using microwaves, stretch strings and air columns, and explain the formation of stationary waves using a graphical method and identify nodes and antinodes. Alright, so first of all, যে জিনিসটা দরকার is the basic conception of a standing wave, like what exactly it is. So এখন পর্যন্ত আমরা যতগুলো ওয়েভ পড়ছি, what sort of waves were they called? Transverse longitudinal, but basically what we're saying is progressive waves, right? So when a wave is said to be progressive, এর মানে কি? That means that doesn't mean that the particles are moving in a specific direction. Oops. That doesn't mean the particles are moving in a specific direction. What it does mean is that there is a net transfer of energy. So as a wave travels, energy goes from point A to point B, or wherever the wave is traveling. For example, you drop a stone into a pond, you get ripples. Which way are the ripples traveling? Outwards, which means what? Energy is being transferred outwards. Mone rakhba kintu eta jokhon hoy, none of the water molecules are actually traveling from here to here. Eta to tomra shobai jano. Which way are the water molecules moving? Up and down, right? So if the transfer of energy is in this direction, then you can say that the water molecules move like this. This is exactly what a transverse wave is, right? Acha, so eta gelo tomar the idea of a progressive wave. Now if you take two progressive waves, ঠিক আছে, and you make them travel in opposite directions, same type of wave along the same plane and everything, তাহলে which way would you get net transfer of energy? Which way would you get net transfer of energy? You wouldn't get any transfer of energy, right? Because they'll cancel each other out. So যেটা বলতে হবে, there is no net transfer of energy. Right. So ঠিক আছে, এটা গেল. That's how you create a stationary wave, where you have two progressive waves of the same type traveling in opposite directions. Now, what would you see? যখন এই জিনিসটা হবে, তুমি কি দেখবা? So before we go there, we have to understand that waves, when they meet at the same point, what do? They do this thing, it's called interference. So they will interfere. So let's talk about the basics of interference first. So first of all, you take a wave like this. এরকম একটা wave আসলো. So this is just one wave pulse. বুঝছো? So এরকম একটা wave travel করতেছে ধরো এইদিকে, and we take another wave which is traveling from the opposite direction, and say এটাও একটা wave pulse. ঠিক আছে? So this is traveling in direction here. Now you're going to get different situations. এখানে একটা পয়েন্টে you're going to get যে এই ওয়েভটা will perfectly overlap itself. তাই না? একটা টাইমে তো এটা হবে. So what's going to happen? If this is on a string, ঠিক আছে, একটা string এর মধ্যে ধরো তুমি দুই পাশ থেকে ডিস্টার্ব করে দিলো, তাহলে the wave is going to travel in opposite directions on the string. এটা যখন হবে, what will happen to a stringer? What's going to happen to this point of the string? এইখানে এই পয়েন্টে কি হবে? খেয়াল করো, amplitude এদিকে প্লাস a হইতেছে, আবার অন্য ওয়েভেরও প্লাস a হইতেছে, তাই না? And the same thing is happening here, just minus direction. So what would you see? What you're going to see as a result of this is going to be the addition of the two waves, which leads to a large amplitude wave. What's the জিনিসটা? So this is called constructive interference. Alright? This is the basic concept of constructive interference. So for constructive interference to occur, obviously same type, A shape, blah 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 সব হতে হবে। সাথে কি হইতে হবে? They have to be in phase. ঠিক আছে? The waves have to be in phase. Which basically means দুইটার crest, দুইটার trough সবকিছু একসাথে meet করতে হবে। তখন গিয়ে when you have waves meeting in phase, তখন you get constructive interference. Does this make sense? Alright. So if this was like more than one wave, আরো কয়েকটা wave যদি হতো, একটা পয়েন্টে you'd also get another sort of pattern. কিরকম প্যাটার্ন পাইতা? একটা ওয়েভের এরকম প্যাটার্ন পাইতা, আর আরেকটা ওয়েভের এরকম প্যাটার্ন পাইতা। Does this make sense? দুইটা আমি just একটা dotted line আর একটা solid line দিয়েছি। So তখন গিয়ে if this is again on a string, which way would the string move here? কোনো দিকে মুভ করতে না, কারণ এদিকে মাইনাস এ আর এদিকে প্লাস এ, রাইট? সো ইফ উই ডু দ্য ভেক্টর সাম অফ দ্য টু, ইউ গেট হাউ মাচ? 0, সাম তো অ্যাড করা। সো অ্যাজ এ রেজাল্ট হোয়াট উড ইউ সি? ইউ গেট আ ফ্ল্যাট লাইন, ঠিক আছে? এটাকে কি বলা হয়? ভেরি গুড, দিস ইজ কল্ড ডিস্ট্রাকটিভ ইন্টারফারেন্স। This is called destructive interference. Can anyone tell me, should they be in phase? Should they be in phase for destructive interference? Yeah? Wrong. They have to be anti-phase. ঠিক আছে? They have to be anti-phase. So in phase, এর মানে phase difference কত? 0 degrees. Anything else than 0 degrees is said to be out of phase. ওই out of phase এর মধ্যে স্পেশাল একটা কন্ডিশন হইতেছে when we have a phase difference of how much? 180 degrees. তখন গিয়ে what we call this is antiphase. So when waves meet antiphase, তখন it is destructive interference. Does this make sense?
Yep.
Alright. In phase and antiphase. Antiphase is just a type of out of phase. Does this make sense to everyone, guys? কার কোনো ডাউট আছে যত বলতেছি? Alright. Now, এখন if we were to এই জিনিসটা, if we were to continue this, like on the string, যে constantly এখন আর wave pulse না করে, we have a constant wave, continuous wave train বা হয়তো continuous wave, আর এই পাশ থেকে আবার এরকম একটা continuous wave, দুই পাশ থেকে দুইটা এরকম আসতেছে, ঠিক আছে? তখন কি হবে? তখন what you're gonna get is একটা পয়েন্টে obviously throughout the whole thing একটা wave এরকম হবে আর একটা ওয়েভেরও এরকম হবে, right? তখন what you're gonna see, you're gonna get large amplitude waves, এরকম বড় amplitude waves পাবো। মানে খেয়াল করো wavelength কিন্তু চেঞ্জ হবে না, ঠিক আছে? wavelength কেন চেঞ্জ হবে না? because there's nothing to change the wavelength, there's nothing to change the frequency, all we're changing here is the amplitude. তারপরে next হইতেছে একটা পয়েন্টে যখন এই যেটা সলিড লাইন আঁকলাম, let's imagine this is moving in this direction, যেটা ডটেড লাইন, let's imagine this is moving in that direction. তারপরে কি হবে? তাহলে সলিড লাইনটা ধরো এরকম একটু আগায় যাবে, হ্যাঁ, আর ডটেড লাইনটা একটু এদিকে মুভ করবে। সো লেটস সে ইট মুভস টু হিয়ার, ঠিক আছে? এরকম হলো, রাইট? তখন কি তোমার কি হবে? তখন কি ডিস্ট্রাকটিভ ইন্টারফারেন্স হবে, কারণ দেখো একটা ক্রেস্ট আর একটা ট্রাফ they cancel each other out, you get a flat line like this. তারপরে নেক্সট ইনস্ট্যান্ট গিয়ে কি হবে? আর একটু আগাবে, তাই না? আর একটু আগাইলে ধরো তুমি এই ওয়েভের এইরকম পাইলা, আর অন্য ওয়েভে তুমি এই ডটেড লাইনেরটা এইরকম পাইলা, আর একটা টাইম ওভারল্যাপ করবে। সো এটাকে what does this cause? Constructive, but it's opposite to this, right? সো এটাকে কি রকম হবে? এটা একদম উল্টা এরকম হবে। I'm trying to draw this as nicely as possible. And then if we draw it quickly, next moment গিয়ে কি হবে? আবার তোমার একটা সলিড এরকম হইলো, আর ধরো আরেকটা ডটেডটা এরকম হইলো, ঠিক আছে? ঠিক আছে? তখন গিয়ে you get destructive again here, তখন গিয়ে you get a flat line. এখানে একটা জিনিস ইম্পর্টেন্ট, this is one complete cycle, ঠিক আছে? তাহলে complete cycle এর you start off with this. So if the time period for the oscillation is capital T, this will happen at say T is equal to ধরলাম 0, okay? তাহলে এটা কততে হবে? This will happen at T is equal to 1/4 of the cycle. Do you get it? 1/4 of the cycle, because how much of the wave has moved? ওইটার half, তাই না? বুঝছো জিনিসটা? So this occurs at 1/4. half of বলাটা ঠিক হবে না, it's actually এইটার 1/4 আর এটার 1/4. So opposite direction move করার পরে now they've overlapped antiphase করে। At T half you would get this, ঠিক আছে? Which is basically 2/4. T 2/4 or basically half time এটা হবে। তারপর এটা কততে হবে? 3/4. Navid, shut up. So T is equal to 3/4. তখন you get this flat line এরকম। Is this making sense?
Yes.
এখন couple of things you can notice here. Number one is if we focus on this point, এই পয়েন্টটা it never ever moves. Notice করছো? এই ডায়াগ্রাম একটু এদিকে চলে গেছে, যে এই পয়েন্টটা আবার এইখানে, this point never moves, তাই না? Same with this point, same with this point, same with this point, all these points they never move. And if you take this point, এটা কি হয়? এটা large amplitude oscillations হয়, তাই না? This is always moving. It's passing through the origin, obviously, sorry, the equilibrium point, but it's always moving large amplitude oscillations. Alright, তাহলে the points which never move, এই যখন এই জিনিসটা হইতেছে, points which never move. কি নাম এগুলার? These are called nodes. And points which move to maximum amplitude? Move to maximum amplitude. এগুলাকে বলা হয় antinodes. এখন আমাকে এটা বলো, using your common sense or whatever you have. এই যে one node থেকে আরেকটা node, হ্যাঁ? How much of a wavelength is this? Wow. So one antinode থেকে আরেকটা antinode? Yeah, Maxwell known na bolo. So antinode to antinode is what? Lambda or half lambda? Half lambda. সবাই বুঝছো এই জিনিসটা? So now we'll have to draw it like মানে a little better কারণ অনেক বাজে আছে এখানে. So one of the first things you have to understand is T0 আমরা এখানে দেখাচ্ছি যে maximum amplitude. What if T0 was flat? তখন কি হইতো? T 1/4 তারপরে হইতেছে T কি জানি 3/4 তারপরে 2/4 3/4 right? তখন এটা ফ্ল্যাট হইতো at T0 তারপরে T is equal to 1/4 তুমি ধরো এইরকম পাইতা তারপরে T is equal to 2/4 which is half এখানে গিয়ে ফ্ল্যাট পাইতা আবার T is equal to 3/4 এখানে গিয়ে কি পাইতা উল্টা এইরকম then 3/4 এর পরে কি T আবার কি 4/4 মানে one complete cycle হয়ে যেত তখন গিয়ে কি এই জিনিসটা আবার হইতো does this make sense alright so that's how we get the cycle keep on going so এটা গেল now number of things. Number one, you have to understand what a node is and what an antinode is, and also you have to know how to draw standing waves. So, when you have to draw a standing wave or a stationary wave, how do you draw it? So, I'm going to try drawing it. So, this is one wave. Oh my God! So, a point is never moving. Neither is this point. And a two point is not moving. এখন if we were doing this on a string একটা সুতার মধ্যে যদি করতাম তাহলে কি is it possible for the ends to move no কেন এগুলা these are the ends that we're going to get মানে আটকায় রেখে দিব right two ends of a fixed string তাহলে গিয়ে ওই দুই মাথা always has to be a node does this make sense node this is a node this is a node and these are antinodes এটা একটা antinode এটা একটা antinode এটা একটা antinode a and A. So this is how much? Half lambda, right? Is this clear to everyone? Really simple. Achha. Now I would like you guys to see an animation of this. This is an animation of a standing wave. Alright? So if you notice, if you pay attention, you can see a couple of things. So the first thing that you notice here is we have these nodes, right? So this is a node. This is a node. Everyone can identify these really well, right? Node. This is a node, and this is a node. These points, do you see how? So first of all, let's focus on the nodes first. So at any point, দেখবা যে একটা ওয়েভের যখন এখানে ম্যাক্সিমাম আসে, তখন অন্য ওয়েভের এখানে মিনিমামটা আসবে। দেখছো? Are you paying attention to it? And এছাড়া হইতেছে অন্য একটা ওয়েভের যদি একটু বেশি আসে, say this much of one wave. Then অন্যটারও exactly ততটুকু আসবে so it always leads to equal destructive interference it's always antiphase here alright তারপরে let's take this point যে point we called it an antinode এখানে if we pay attention what we can see is দুইটার দেখো এই যে দেখছো দুইটার ট্রাফ একসাথে মিট করে আবার এখানে দুইটার ক্রেস্ট একসাথে মিট করতেছে right it's always in phase that's why কি হইতেছে constructive interference alright is everyone getting this so this is an antinode abar this is an antinode and obviously if you were to see it for an instant তুমি কি দেখতা one node to another node is only half a wave ঠিক আছে so internodal distance কতটুকু half lambda this is half lambda is everyone clear on this কারণ doubt আছে alright so yeah this is very simple straightforward easy way to understand how জানি বলো waves work তারপরে the next thing that we need is আচ্ছা এরপর আরেকটা অ্যানিমেশন আছে দেখাই this is a little more here the points aren't marked out easily and the lines are a little thick but বোঝা যায় এখানে for example এই যে we can identify this as a node তাই না are you guys following this then we can identify this as a node look আমি যে জায়গায় পেনটা ধরছি it's never moving is it so this is a node আবার ধরো এই পয়েন্টটা যদি ধরো এই যে এই পয়েন্ট look it's going to maximum which is up here আবার it's going to minimum let's see how high up it goes up to this height এইটা and the blue one and the red one, they go up to this much. Our equilibrium point is around here. So are you noticing this is twice the amplitude?
Yeah.
Same thing is happening on this end. We take this point, what we see is that এখানে is going to half of the amplitude again. So this is how you get standing waves. So you have nodes and you have antinodes. This is an antinode, this is another antinode. So the distance from one antinode to the next is again half lambda. Alright, so I believe everyone's cleared that out. So that should clear out the basic concept of standing waves. Now, if we go back to this, if you create standing waves on a string, you're going to come across some interesting things. Number one, say you take this length of string and you place a node here. So place মানে কি? এখানে তো node করতেই হবে because the string is stuck. So what's the longest wave you can fit on this string? What would be the longest wave you can fit on this string?
The whole thing will be one wave.
It's going to be half a wave. The whole thing would be half a wave. So how would we draw the wave? We'd draw it like this. And not this ugly. Looks like a whale. So এটা বুঝছো? So how long is the wave actually? It's actually এত গিয়ে তারপরে আরো এতটুকু এদিকে. Right? So if the string is L, what is the wavelength?
2L.
Lambda is equal to 2L. Say this is the longest wave you can fit, right? C is equal to F lambda or V is equal to F lambda. So which means what? The longest wavelength will have the lowest frequency. Right? And again, we're assuming the speed of the wave is constant. So we can say this is the lowest frequency we can fit here. So this is the fundamental frequency for this string stuck between these two ends. Alright. Now, if you increase the frequency at which you're disturbing the string, what would be the next wave you can fit here? খেয়াল করো, there's only one requirement. Requirementটা কি? এই মাথায় নোড থাকতে হবে, এই মাথাও নোড থাকতে হবে. So what would be the next wave you want to fit? You can't fit stuff like this. Does this make sense? Because So now what you can get, yes, you'll get a node here, and মাঝখানে you can put in another node. Oh my god. You can put in another node, so it's going to be something like this. আর এটা এরকম হবে. এত পর্যন্ত বুঝছো? Guys, does this make sense? So তখন what are we getting? This is an antinode and this is an antinode. আর এটা গেছে, this was the antinode, তাই না? Alright, so এখন এটা, if the string again is L, what is the wavelength? বলো আমাকে? Lambda is equal to L, and the frequency is going to be what? You halve the wavelength, তাই না? So if you halve the wavelength, তাহলে এটা হবে 2F. ঠিক আছে? Does this make sense?
Yeah.
Alright, so fundamental frequency double korla. ঠিক আছে? Then you get 2F. So what's going to be the next thing you're going to get? It should get really easy now. What's the next wave you can fit on the string? So আমরা মোটামুটি ক্যালকুলেশন না করে you can jump to this, right? So এটা গিয়ে কততে হবে? Lambda is equal to how much? খেয়াল করে, the whole thing is L, one wavelength is this much, which is 2/3 of the value, right? 2/3 L. আর frequency কত হবে? It's going to be 3F. তাই না?
Yeah.
So yeah, so if the string is say 90 centimeters, here how much is our wavelength? 60 centimeters. Do you get this?
Yeah.
So it's really easy. So you increase the frequency. So progressively, আমরা যদি নেক্সটটা করতাম 4 এ, তাহলে কি হইতো? Like blah blah blah. So তখন কি lambda তুমি পাইতে হইতেছে half, মানে 2/4 তো. So 2/4 করলে you get half L, and it's going to happen at 4F. এত বুঝছো?
Yep.
Alright. So this is very easy. So yeah, this is called the first harmonic. Alright? You get it? This is the second harmonic, third harmonic, fourth harmonic. Harmonics progressively বাড়ে. Now the interesting thing is you can do the same thing with sound. এটা? ওটা কপি করা লাগবে? You find it on YouTube. You can pause it and then copy it there. Bookletও আছে, নোটসও আছে, Google করলেও পাবা, YouTubeও পাবা, সব জায়গায় পাবা। ঠিক আছে? Alright, তারপর let's move forward. You can do the same thing with sound. ঠিক আছে? Sound দিয়ে কি হয়? একটু pay attention to this. What we can do is we can take a pipe. ঠিক আছে? And we close one end and we keep the other end open and we put a speaker here. ঠিক আছে? So this creates a sound which travels through the pipe, hits the closed end, and then reflects back again. Should I would say that? Really simple. So here what happens is, again, any wave can create standing waves. So again, a sound will create standing waves with a node at the closed end. This is the rule for closed ends. The closed end will always have to have a node, and the open end has to have an antinode close to it. Because not exactly at this point, it's going to be somewhere out here. There's a difference. There's a small difference, right? End correction. So what's the longest wave we can fit in here? If I try drawing this, there's going to be a node here, and there's going to be an antinode here. Node here, antinode here. So how long is the wave actually? If you try to draw this, you see the entire wave is going to look something like this. So if the length of the tube is L, so lambda is equal to 4L. And the frequency, jehetu this is the longest wave we can fit, we can call this the fundamental frequency F. Alright, we take the tube again. Same rule, we're going to node, and we're going to antinode. What's the next wave we can fit? It's going to be something like this. Right? So roughly, this is what I'm trying to draw. So you're going to get a node here. You're going to get another node here. Antinode and an antinode. So how much of a wave is this? To complete it to one complete wave, you'd have to draw this much, which would be 1/4. So L here is 3/4, right? So again, for example, L is how much? 1/4 of a wave? 1/4 of lambda. Whoops, my bad. 1/4 of lambda. Again, L would be equal to 3/4 of lambda. So, lambda would be how much? It's a reciprocal, which is 4/3L. And frequency would be how much? 3F. 2F hobe na. 2F korte hole tomar ei mathay node ante hoito. Do you get it? So that's why erokom tube you'll never get even numbers. The next wave that you would be able to fit here would be something like this. Right? So erokom korle ekhane tumi abar antinode peye jaccho, which is alright. So again lambda kotoruku? Lambda is no longer longer than the tube. L is equal to how much? Now it's going to be 5/4L lambda, and lambda is equal to how much? 4/5L, and frequency is 5F. So now you can actually show this. Say, for example, if you take one of these tubes, and you pour sawdust here. You're going to sawdust to pour koro. What are you going to observe? Yeah. So basically, what you're going to see is you put a speaker here. There was a sawdust as sound travels, and it creates a standing wave. It has to be a frequency which perfectly matches the wavelength which can fit. তখন কি হবে? তুমি এখানে একটু পাবা, ঠিক আছে? এখানে একটু sawdust accumulate হবে, এখানে ধরো আবার আরেকটু sawdust accumulate হবে, এখানে আবার sawdust accumulate করবে, ঠিক আছে? আবার এখানে একটু accumulate করলো, ঠিক আছে? You get something like this. So what does this show? It shows that these points are what? Nodes. So these are nodes. So let's try drawing the wave which would cause this. Oh, I'm really bad at this. Oh my God. So yeah, there you go, right? So if you take a scale and you measure the distance from here to this pile, so what do you have? You're going to get, say, it has 120 centimeters. So what is your wavelength?
Wavelength is 80 centimeters.
Yeah, it's going to be 80 centimeters. Another way of doing it is you just find out if it's 120 centimeters, what's the distance between one node to the next? It's 40 centimeters. Right? So 14 to 2 is 80 centimeters. Your lambda is going to be this. Is this clear? Alright, so you can even find the speed of sound tahole. How are you finding the speed of sound? Tumi just sound use kortecho. How are you creating it? You have a frequency signal generator connected to this loudspeaker. So এটা কি sound pick up করতেছে? Sound pick up করে তো এটা absorb করে নিচ্ছে। তাহলে কি টিউবের মধ্যে যাচ্ছে আবার রিফ্লেক্ট করে ফেরত আসতেছে। So you know the frequency, right? And you know the wavelength. So what can you find? Speed of sound, C is equal to F lambda. Done. তাই না? So you can use standing waves to find the speed of sound. এত পর্যন্ত clear? Alright, so this is the basics of standing waves. Let's quickly review all the points that I said so far. So what did we talk about? We said that you can get standing waves when you have two progressive waves moving in opposite directions, Taina? When they move in opposite directions, they can either interfere constructively or destructively as long as they're moving along the same plane, blah blah blah, all of those things. And the pattern you get will have a very specific motion, and that can be seen here, right? So this is basically a standing wave where these points which never move are called nodes, and the points which always move are called antinodes. Taina? Alright. Tapure, what did I say? We found out the locations of nodes and antinodes and all of these sort of things, blah 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 blah. Again, there's this important thing which I haven't mentioned, Kintu. I would like you to pay attention to this one. If you take the points between two nodes, alright, say we see all the points from here to here. When this goes to maximum, a point is on maximum, that's it. A point ki tar maximum, that's it.
Yeah.
So what is the phase difference between these points? Roughly zero, Taina? Because they all kind of reach their maximum together. So we can put this in as a definition to ki hobe, or a law. 2 points between the same nodes, points between the two successive nodes. The law would be what? Points between two successive nodes are always in phase. And amra the ekta node dui pache nei, doesn't matter where you take it. I can take, say, this point here, and I can take randomly this point here. What can we say about these 2 points? These are always going to be antiphase. Eta jokhon dekho, eta jokhon ekhane maximum hoye jacche, oita tokhon negative maximum hoye jacche, right?
Yes.
Is this making sense? And between two nodes, all the points are always in phase. And then again, these are in phase with who? These guys over here. Okay, so they will be in phase. Eta jokhon minimum hoye jacche, tokhon eta minimum hoye jacche. Eta jokhon maximum hoye jacche, eta maximum. So between two nodes, all the points are in phase. And ekta node dui, all the points are always antiphase. 180 phase difference, doesn't matter where it is. Is this clear to everyone? Alright, so yeah, that would be the basic conclusion of standing waves. If you see the points, standing waves, blah blah blah, stretch strings and air columns. Is this clear to everyone? Explain the formation of stationary waves using a graphical method and identify nodes and antinodes. Shesh, stationary waves. Clear?
Yeah.
Okay. Tapor ki korba?